Good morning, all. Due to network issue, somewhat problems are there. Uh, First of all, sorry for the late joining because of college internet. Even my mobile internet is also not working properly, so that late to join the meeting. But uh, Okay, so in last lecture, the last point of a unit number 5 is remaining, that is AC stabilizer, also called as AC chopper. Okay, so AC chopper, that is AC to AC, from lower voltage to higher voltage, or from higher voltage to lower voltage. That is possible with this type of chopper. Even variable AC, or that is called maybe unconstant AC, we can say, to constant AC. Such type of stabilizers we are using at our home appliances for television, for fridge, etc. So that is the basic circuit of AC stabilizer, or you can say AC chopper. So AC chopper can be achieved with the help of triad circuitry, but sorry. Okay, so triac is somewhat a low power low power device as compared to SCR. So triac can be used, but in place of triac, here the two SCRs which are connected anti-parallel is used in a circuit for the AC stabilizer. The load is the AC output and input is also a AC, right? So we are using here four SCRs, right? So that four SCRs are maybe two SCRs anti-parallel. Again, these are two again anti-parallel. This forms a bridge actually, right? So AC chopper or AC voltage magnitude can be changed by two methods. The well-known method first is by means of step up or step down transformer. This is also possible to have a step up or step down transformer, so that you will get a lower voltage or higher voltage. In this method, the change in voltage depends on the value of transformer ratio, of the transformation ratio of the transformer. The second method of a changing magnitude of AC voltage is by means of solid state switch. In this method, the AC input voltage is switched on and off periodically by means of suitable switch. So second method is used actually here. That first method is not convenient because uh, the design of a transformer for high power application is very difficult. Even the size of transformer increases as your power rating increases, right? So transformer, every time to use step up or step down transformer is not a convenient solution for AC to AC conversion. So in place of that, the second method, that is changing magnitude of AC voltage by means of solid state switch. In this method, the AC input voltage is switched on and off periodically by means of suitable switch. Okay, so voltage changing circuit employing semiconductor devices and static switch are known as AC choppers. Again, the switches used in a DC chopper and switches used in a AC choppers are again same. So if we are using a power devices or maybe a power SCR, then definitely it requires uh, protection circuit, it requires triggering circuit, it requires commutator circuit, etc. That circuits are not shown in a figure, but remaining is shown. So in this circuit, SCR1, SCR2 are the main SCR, whereas SCR3, SCR4 are the auxiliary SCR, also called as a pilot SCR. Okay. Then C1, C2 are the commutating capacitors, and diode D1 and D2 provide the charging path for the capacitor. Okay. So this is about the circuit diagram. The thyristor T1 and T3 form the first pair of producing positive alternation, and T2 and T4 constitute the second pair of producing negative alternation of input voltage. My dear student, this circuit is very similar to the full wave bridge rectifier. Only the SCRs are used in place of diodes. Okay, so T1 and T3 conduct at the same time because the direction of T1 and T3 is the same, and T4 and T2 is conducted at the same time. Your direction of T2 and T4 is same. Okay, so this forms a bridge rectifier, but simply diodes are replaced with the SCRs. Okay, so then this circuit will works in different modes. So that we will see first. Mode 1. Initially during the positive half cycle of a supply voltage. This is the operation working, you can say. So this is AC to AC. So we consider that first positive half cycle, or you can consider for negative also. Okay. In a DC circuits, we start our working with turn on DC supply, right? But in AC circuit, the working of circuit will start with the positive half cycle. Every time we use first positive half cycle, and whatever the circuit operation during positive half cycle, that we first understand. And then we will apply negative half cycle. Again, we'll consider the working of second half cycle, or maybe a circuit in a negative half cycle, so that the complete working will be over, right? So initially during the positive half cycle of supply voltage, the capacitor C2 charge through the path L, C2, D2, R2 and M, right? So this capacitor C1 charge with the path L, C2, D2, R2, M, right? So capacitor C2 will charge through the D2, R2 actually, and L, that is the terminal name. Okay, so single phase supply L, then C2, then diode D2, then R2 back to the M. So this capacitor will charge, right? Then with the polarity as shown in figure, similarly during the negative half cycle of the supply voltage, capacitor C1 charge through this R1 D2, or M, R1 D1 and C1 back to the L. So you can check here M, R1 D1 C1 and back to the L with the polarity as shown in figure, right? The voltage across these capacitor is used to commutation of a main SCR T1 and T2. Okay, so these voltages is used to commutate the SCR T1 and T2, that is the main SCR. Okay, so normally what is the meaning of this? Initially when supply voltage starts, as soon as you apply the trigger impulse, this SCR will trigger, right? Okay, so this SCR will trigger, output current will flow to the load, you will get an output voltage, right? But depending upon the value of this R, we can change the firing angle, or you can say the commutation angle of the particular SCR. So as the capacitor slowly charge, right, whenever the anode voltage is more negative than the supply voltage, then SCR turns off. Okay, similarly this T2, the cathode voltage is more positive as compared to the anode voltage, anode voltage, then thyristor T2 turns off. Okay, so these capacitors are just used for commutation purpose, otherwise no use. Now what is in every circuit, we have seen that commutation circuit is required, etc. So this is a simple commutation circuit. We use one diode, one resistor. This resistor should be a variable resistor, so that you can change the commutation angle, or you can say the conduction angle of SCR. Just see this working alpha. So at this particular instant, you are turning on the thyristor T1. It remains on for to this. At this instant, you can check. At this instant, the voltage across capacitor is more as compared to the supply voltage. Okay, the voltage across capacitor C1 is more negative than the supply voltage, so that the thyristor T1 turns off. Right? It means that the anode voltage is decreases below the holding current, right? So that your SCR turns off. So SCR turns on करायचा आहे. So definitely the on time, whenever you apply the trigger impulse to the gate of SCR, it turns on, right? But how to turns off the SCR? That is most important, and that is given here. So you can check here. This is a beta conduction angle, but at time T2, the SCR T1 turns off. At time T1, T2, the SCR T1 turns off. How it turns off? Supply voltage is given, right? For example, this is a sine wave. Okay, at this instant, SCR turns on, depending upon trigger impulse, right? Then it turns off at this particular angle. Okay, how it achieved? This is achieved with the capacitor voltage whenever the capacitor voltage is more negative than the supply voltage, or you can say this capacitor voltage will reduce the anode current below holding current so that the thyristor T1 turns off at this particular end. So this is achieved with the voltage across capacitor C1. Similarly, capacitor C2 is used to turn off this thyristor T2. Okay. So mode 1 as shown in figure above. During the first positive half cycle of supply voltage, thyristor T1 is triggered at instant T1 with the firing angle alpha. Okay. The current flow the path L SCR1 load M. So that time the current flows from L SCR1 load and back to the M, as already I told you. Okay. Then when the instantaneous voltage reaches the instant T2, the auxiliary thyristor T3 is triggered. Okay, the auxiliary thyristor T3 is triggered. I'll just show you the auxiliary thyristor T3. This will be triggered, right? So when this will be triggered, the voltage will deliver through this thyristor T2 and will be available here at the anode of SCR-T1, right? So this voltage, if it is more positive than this voltage, then SCR-T1 turns off. Okay, so this auxiliary SCR turns on at time instant T2. At this instant, the auxiliary SCR T3 turns on. As T3 turns on, the capacitor start to discharge. See here, as soon as the T3 is triggered, the capacitor C1 start discharging through the path CB, T3, T1 and CA, right? So capacitor C1 will discharge through CB, B point, then T3, then T1, then back to the A, that is the CA. So that the voltage across capacitor, if it is more positive as compared to the anode voltage. See, just for example, with the help of this waveform, here the voltage across the T1 anode voltage is equal to 5 volt. Say for example, right? So capacitor is also charged up to the 5 volt. Okay. So as soon as this is depends upon the value of resistor. Huh? So capacitor C1 having a 5 volt, right? Now this line voltage is decreasing. As soon as it is 4.9 or below 5 volt, immediately what happens? The voltage at the cathode, this capacitor T3 turns on. So capacitor T3 start to discharge through this. So the voltage at cathode is 5 volt, right? And voltage at anode is 4.9 volt, ideal condition, right? So anode voltage is less than cathode voltage, the SCR T1 turns off. This is called as a force commutation method. So SCR T1 turns off. When the discharging current of capacitor C1 becomes more than forward current of SCR-T1, SCR-T1 becomes turns off. The auxiliary SCR-T3 will be automatically turns off at instant T3 because of zero current at this instant. So at this instant, the T3, the auxiliary SCR automatically turns off. Hence, the SCR T1 and T3 form the first pair of producing positive alteration of AC input voltage. So this is the AC input voltage, positive part that is produced with the help of T1. So at time T1, thyristor T1 trigger, and at time T2, thyristor T3 trigger. At this instant, T3 also turns off. At this instant T1, so you can say this is a T1 on time, this is a T3 on time, right? T3 on time. Here T1 on, if you have T3 on. Now at this instant, T2 on, right? And at this instant, T4 on. Okay. So mode 2 operation. For the formation of negative alteration, this is a similar to the mode 1 operation. Okay. So I'll just read it. For the formation of negative alteration, second pair of thyristor T2 and T4 are used. The main SCR T2 is triggered at the instant T4 as shown in figure above. During first negative half cycle of input voltage, the current flows through the path M, load T2 and N. When the instantaneous voltage reaches the instant T5, SCR T4 is triggered. As soon as SCR T4 triggered, the capacitor C2 will discharge through the path CC, T2, T4, A, K, CD. This when this discharging current is more than load current, then SCR T2 becomes turns off. At the instant T6, SCR4 automatic discharge or turns off due to the zero crossing point. Okay, and this will be repeated. So this is AC converter, right? When you calculate, when you found the average AC voltage is definitely lower than the applied input voltage. Okay, so this is a AC stabilizer. If input is 230 volt and if you required load voltage equal to 200, then set the value of resistor in a proper value, then definitely the load voltage is maintained to the 1200 volt constant. If your input voltage increases, automatically the firing angle or conduction angle of SCR increase or decrease, but load voltage is maintained to the constant. Okay, so this is about the last part of unit number 5. uh, I'll share the PPTs of unit number 5 with you as soon as the lecture is over. Even the PDF file of MD Singh and Khanchandani for your reference purpose. I have taken the all topics, all points from the MD Singh and Khanchandani, at least for unit number 2, 3, 4, 5, and 6. Right? Unit number first I have taken from other books, but these remaining unit, that is a Mazidi, sorry, Rashid. Unit number 1 I referred from Rashid, but unit number 2, 3, 4, 5, and 6 I referred MD Singh and Kanchandani. So I have a book chapter, so I'll share that chapter, that is PDF file of converter, inverter, chopper, as well as the last one applications with you. But before that, we will start the unit number 6. Okay. Uh, even on 13th, as well as on 17th, uh, and maybe onward that our lecture is continuous. The Diwali holidays are 14, 15, I think, and 16 only. Okay, so remaining days your lectures is continuous till the end of this November. We have to cover all 6 units. So already we have covered total 5 units, right? If you are having any questions on unit number 5, you can ask me. Otherwise, we'll start the unit number 6 immediately. So I'll just give you 1 minute to ask questions. If your questions increases, then definitely I'll continue the question and answers. But if you are not maybe asking any question, then we will go for the unit number 6. Okay, if there is a no question, then see the syllabus of unit number 6. Uh, until now, we have seen, in the first unit, we have seen the types of power devices, right? Or electronic switches, that is for high power applications. Even BJT diode is also an electronic switch, but for high power application, we use the power devices only. Maybe power MOSFET, power IGBT, TRIAC, SCR, etc. Mostly power MOSFET, IGBT, and SCRs are used. So in your syllabus, these three devices are mainly focused. With the TRIAC is also one of the device is used in a power circuit. So that is also focused in unit number 1. So in unit number 1, we have seen the construction of a power devices, then working of power devices, steady state or static characteristics of power devices, then switching characteristics of power devices. Okay. So in the second unit, we have learned the protection circuit for these power devices. Then in third unit, we have started the application or use of these power devices in different power circuits like power converter, then power inverter, then power choppers, right? So these are the 3 units in which we use these power devices, right? Now These circuit, that is converter, inverter, chopper. Now these circuits are used in some applications. So that applications are given in unit number 6. So first point, HVDC transmission system. So HVDC transmission system uses converter as well as inverter, right? Then UPS itself is one of the converter as well as inverter. Then that is online UPS, offline UPS, concept of online offline UPS. Then battery charger, then power electronics in battery charging applications, power electronics in induction heating, electronic lamp ballast, power electronics for electric drives, then other applications, selection of power converters for different applications, just introduction. So the main part of this unit is HVDC transmission, okay, HVDC transmission, then UPS, then battery charger, then electronic lamp ballast, then induction heating. These are the applications. One, transmission; second, or UPS; third, battery charger; induction heating; fourth, electronic ballast; fifth. So these are only 5 applications which are given in your syllabus. Okay. So we'll start with the first one. Okay, now power electronics. Before that, just the introduction. Uh, Power electronics and motor drives constitute a vast, complex, and interdisciplinary subjects that has gone through rapid technological evaluation during the last 4 decades. As the technology is advancing and apparatus cost is decreasing along with the improvement of reliability, their applications are expanding in industrial, commercial, and residential, military, aerospace, utility environment, right? So these are the application area of a power electronics. Many innovations in the power semiconductor devices, convert topology, analytical and simulation techniques, electrical machine drives, and control and estimation of techniques are contributing to this advancement. The frontier of technology has been further advanced by the artificial intelligence. Nowadays, the artificial intelligence like physiology and artificial neural networks is also involved in the power electronics. So that is maybe the main advancement that is in 21st century. Sorry. Now, power electronics is used in all the era, in industry, in automation, in home appliances, right? So, in power electronics, there will be some advancement, not only using SCR and technology. Initially, UJT is used as a triggering circuit. Nowadays, a smart triggering circuit ICs are available in the market. So, with the help of that triggering ICs, you can use uh, the triggering circuits and you can make your power circuits smarter, right? So that is the advantage of a 21st century in which the power electronics is or the applications is increasing vastly. So one of the most important application of a power electronics, or you can say power circuits or power converter, is a high voltage DC transmission system. Now, whatever transmission systems we already have seen, maybe on road, maybe from one place to another place, that is AC transmission system. Okay, the AC transmission system has various disadvantages. Okay, that the AC transmission lines are always open to air. Then that is in India actually. In foreign country, that AC lines are also placed underground, but in India, that AC lines are open to air. So it is easy to uh, use that energy without any connections. I mean, rural area, most of the uh, peoples use the energy without any meter or any connections, right? So that is basically one of the disadvantage. Then there are so many losses in AC transmission system. And one most important disadvantage, that is number of wires required to transmit the energy from one place to another place. And second one, and that is another important, is to maintain the frequency from transmission from one place to another place, right? And this is very, very difficult to make the synchronization of a frequency from transmitting area to the destination area, right? So that is disadvantages of AC transmission systems. So AC transmission dominate electricity supply by virtue of ace of generation, motor characteristics, and ability to change voltage magnitude using transformer. Definitely, AC transmission having some advantages. So because AC motors are directly work on AC transmission or AC lines, so that motors are less costly, right? Then ability to change the voltage magnitude by simply using step up or step down transformer, that is possible in AC transmission. In recent year, it has been found to be economic to transmit large amount of power over long distance or across water by means of high voltage DC rather than multi-phase AC, right? Because if you want to transmit the AC power from one place to a longer distance, then single phase power cannot be transmitted. So we have to use multi-phase or three-phase power. So three-phase power, it means more number of wires are there, maybe high height towers we have to implement. We have to connect the high tension wires, right? So that the AC power transmit from one place to another place. The saving in a cable cost can pay for the necessary conversion equipment required to connect the transmission system into AC power system at either end. Many hundreds of megawatt of power are now transmitted by this method. Nowadays, this DC transmission method is widely used. This method also has additional very important operational benefit. This is most important in that the two interconnected SIM can be at different frequency and voltage. They do not need to be synchronized together. And DC interconnection does not increase the maximum fault current in either AC system. So in AC transmission, there are disadvantages, that is synchronization is required, that is frequency voltage synchronization is required, then more number of wires required, high maybe range towers are required, right? Then the losses in AC transmission is very high as compared to DC. So nowadays the AC transmission is replaced with a DC transmission. Okay, so DC, it requires only one or two cables, right, to transmit the energy from one place to another place. Then there is a zero loss, and whatever the cost for the wires, more number of wires, that cost you can use to convert the AC to DC first, and at the other end again DC to AC conversion. So whatever circuit required to convert AC at the input side, AC to DC, and at the output side again DC to AC. So that is maybe one of the advantage of DC transmission system. This is a simple and very simple overall layout of a DC transmission system, right? So you can see here at the input side, AC, right? It may be a single phase or maybe a three phase, what it may be. Then filter, just remove the EMI, that is electromagnetic interference. Then transformer, right? And then converter. This is the AC to DC converter. Okay. Then again some filters, so that whatever AC components are remaining, that will be maybe removed. Then DC transmission link. Okay. Then at the other end, there will be a filter circuit which remove the EMI interference in added in the DC voltage. Then again converter. This is a DC to AC converter, and this first one is AC to DC converter. AC to DC, right? And this is DC to AC converter, right? And again transformer and again filter, so you will get again a AC. So main cost, the cost of inverter, this particular circuit is AC to DC converters and DC to AC converters. Okay, so we will see the detailed part in the next lecture. Last 1 minute is remaining, so you all give your attendance in the chat box immediately. Everyone give your attendance in the chat box. Okay, so there are maybe a various types of this DC transmission system, right? So we'll just see above figure. The principle is to rectify the AC power to the voltage level, say plus minus 200 volt kVA, and transmit power over a two cable, or also called as a pole line, to converter operating in the inverting mode, hence feeding power into the other. So AC system, typically each converter would be of 12 pulse or maybe a something 6 pulse converters that is required, but that circuit is complicated and not a part of your syllabus, so I will not show you the 612 pulse converter in here. So these are the types of HVDC transmission system, or maybe types: monopolar HVDC transmission, bipolar, homopolar,